So now we are going to look at where you use logarithms and exponential functions to model real-life situations. And on your exam, you could get any one of these. And what you're going to find is they're going to either give you a formula, because they've decided to take some of these formulas off your formula sheet, and they'll give you a formula instead of having it on your formula sheet. But it used to be that you would get this compound interest formula on your formula sheet, and then you could solve all sorts of things with it. Now, solving questions using the compound interest formula didn't require logarithms unless you tried to solve for t, because t is in the exponent, and how do you solve exponential equations? You have to use logarithms. So we'll go through a couple of questions here. Determine the final value of $500 if after 10 years it's invested at 2.25% compounded monthly. So we go to our formula and we just have to practice what do things mean, what are we trying to solve for. So we want to know the amount. The principal P is 500. The interest rate in this formula is always written as a decimal. If it's compounded monthly, the n value in the formula is the number of compound periods per year. So how many periods per year would there be? 12. And we're looking after 10 years. So this one, we're not solving for anything in the exponent. So all we have to do is plug this into our calculator. Oh, I might even have and type in exactly as you see, 500 bracket 1 plus 0.0225 divided by 12. And make sure you're doing this on your calculator as well to see if you get the same answer. $626.03. Okay, it's important that you try it on your own calculator, because if you can't write the fractions, you have to know how to use the brackets on your calculator to get that value. And if you're not getting that value, then I can help you figure out where those mistakes are being made. So here's another one. Calculate the final value of a $200 investment compounded semi-annually at 3%. So semi-annually means how many times per year? Twice. And after 5 years. So again, should be able to plug in everything into this. I'm cheating. $200. Oh, I froze. Oh, it's still working. I don't know if this was any quicker than retyping it in the end. Oh, man. Semi-annually is twice a year. Is this what you got? $232.11? Yay. Now we're going to calculate the amount of time it would take for an investment to double. $232.11. So we have $30 initially. When it doubles, its amount later will be $60. 1 plus 0.07 compounded monthly. But now we're solving for something in the exponent. And I'm going to give you guys a head start. Use your logarithms figure this out. What I would do in this situation is I would start off by dividing both sides by 30 just to simplify it. If I divide both sides by 30, can you see this side's going to be 2 and this side's just going to be left with this? Now we're solving for t in the exponent. And solving for t in the exponent means that you're going to need to take the log of both sides. You can take log or natural log. So if you take log of both sides, it'll look like this. Wow, that's ugly too. Here we go, that's pretty. And now we can use our log laws to bring that exponent out in front. How would I get t by itself? I'd have to divide by 12 and log of 1 plus 0.07 over 12. So notice, even though the log and the numbers are not nice numbers, and you got fractions and you got decimals, you can still do the same idea. The concept is the same. You want to get t by itself, we'd have to divide by the 12 and by this, and that is a number. Go to our calculator to figure out what this is equal to. So we had log of 2. I'll just type it in quick for you. Divided by 12 log 1 plus 0.07 divided by. And once we get our answer, you can store it as x and you can check if it's actually right. Plug it back into your original equation, 1 plus 0.07 divided by 12 to the power of 12 times t, and you should get 60. If it is, you know that you've got it right.